Hey there, gearheads. Whether you're an aviation enthusiast or a gearhead who loves working on aircraft, this one's for you. We all love the thrill of a powerful engine roaring to life, the sheer force and precision that goes into making it run smoothly. Or the sleek design of a cutting-edge aircraft, a marvel of modern engineering and aerodynamics. But behind every successful flight, there's a mountain of technical documentation. These aren't just papers, they're the backbone of aviation. These documents are like the instruction manuals for building, maintaining and flying these incredible machines. They contain every detail, every specification and every procedure. Without them, aerospace would be grounded. Imagine trying to keep these complex machines in the air without a guide. Think of it like this. You wouldn't try to rebuild a classic car engine without a good shop manual, right? The same principle applies here. It's the same with aircraft, only the stakes are much higher. Lives depend on the accuracy and thoroughness of these documents. Technical documentation provides engineers, mechanics and pilots with the critical information they need to do their jobs safely and effectively. It's their roadmap to success. From the intricate details of engine maintenance, ensuring every component is in perfect working order, to the precise specifications of every single part, down to the smallest bolt and screw, these documents ensure that everyone is on the same page. They provide a common language for all involved. They are crucial for safety, compliance and efficiency in the aerospace industry. Without them, the risk of errors and accidents would skyrocket. So next time you see an airplane soaring through the skies, remember the unsung heroes, the technical documents that make it all possible. Back in the early days of aviation, the industry was just taking off, quite literally. Technical documentation meant stacks of paper manuals, often piled high on shelves and desks. These hefty tomes contained everything from intricate design blueprints to detailed step-by-step assembly instructions. While they served their purpose, they had their drawbacks. The sheer volume of information was overwhelming. For starters, paper manuals were bulky and difficult to update. They took up a lot of physical space. Every time there was a design change or a new safety procedure, new pages had to be printed and distributed, adding to the clutter. This was a logistical nightmare, especially for large aerospace companies with operations spread across the globe. Coordinating updates was a massive task. Secondly, finding specific information within these massive manuals was like searching for a needle in a haystack. It was incredibly inefficient. Imagine trying to locate a tiny detail about a fuel line connection buried within thousands of pages. It could take hours. It was a time-consuming and often frustrating process. The inefficiencies were glaring and the need for a better system was evident. As computers became more powerful and more accessible to the general public, their influence began to permeate various industries. The aerospace industry in particular started to embrace digital documentation, recognizing its potential to revolutionize the way information was managed and utilized. This marked a significant step forward, offering numerous advantages over traditional paper manuals, such as enhanced accessibility and ease of use. Digital documents were easily searchable, allowing users to quickly find the information they needed without sifting through piles of paper. They could be easily updated and distributed electronically, ensuring that everyone had access to the latest revisions and critical updates in real time. This saved time, reduced errors, and improved overall efficiency, allowing engineers to focus more on innovation and less on administrative tasks. Early forms of digital documentation included simple text files and scanned copies of paper manuals, which were a good start but had limitations. While these were an improvement, they lacked the interactivity and visual richness that would come to define the next generation of aerospace documentation, paving the way for more advanced and user-friendly solutions. The advent of 3D modeling software revolutionized aerospace documentation. Instead of relying on static 2D drawings, engineers could now create detailed three-dimensional representations of aircraft and their components. These 3D models provided a far more intuitive and comprehensive understanding of complex systems. Engineers could virtually walk through an aircraft engine, rotate components to view them from any angle, and even simulate their operation. This greatly enhanced the design, analysis, and manufacturing processes. Section 5, Interactivity, takes off exploring aircraft in a new dimension. Three-dimensional models weren't just about visualization, they also brought a new level of interactivity to aerospace documentation. Users could zoom in to view minute details, rotate components to understand their spatial relationships, and even disassemble virtual assemblies to see how they fit together. This interactive capability made it much easier for engineers, mechanics, and trainees to grasp complex concepts and procedures. It allowed them to explore aircraft systems in a virtual environment, reducing the need for costly and time-consuming physical prototypes. Section 6. Augmented reality, bridging the gap between digital and real. Augmented reality, or AR, took the concept of interactive 3D models a step further by overlaying digital content onto the real world. Using AR headsets or tablets, technicians could view digital information such as repair instructions or wiring diagrams superimposed directly onto the physical aircraft they were working on. Imagine a mechanic wearing AR glasses that highlight the exact location of a faulty component and guide them through the repair process step by step. This hands-on interaction greatly improves accuracy, reduces errors, and speeds up maintenance tasks. Section 7. Virtual reality, stepping inside the digital cockpit. Virtual reality, or VR, took immersive learning to a whole new level. By donning VR headsets, pilots and trainees could enter realistic virtual cockpits and experience simulated flight scenarios. This allowed them to practice emergency procedures, familiarize themselves with new aircraft types, and hone their skills in a safe and controlled environment. VR simulations offered a cost-effective and efficient alternative to traditional flight training methods, reducing the need for expensive simulators and actual flight time. This technology has the potential to revolutionize pilot training and enhance aviation safety. Section 8. The rise of the digital twin real-time data takes center stage. As sensors and data analytics became more sophisticated, the concept of the digital twin emerged. This involves creating a virtual replica of a physical asset, such as an aircraft, that is constantly updated with real-time data from sensors embedded throughout the physical counterpart. This means that engineers and analysts can monitor the aircraft's performance in real time, track its maintenance history, and even predict potential issues before they arise. This data-driven approach has the potential to significantly improve safety, reduce downtime, and optimize maintenance schedules.